electronic warfare and GPS jamming is going to be in the battlefield. And if you do not have weapons and navigation systems that can function with that, independently of GPS, then they're going to be in trouble.
Welcome to the second episode in our special podcast series with RAFAEL. In this conversation, we're taking a deep dive into the evolution of long-range precision strike, a capability that's becoming essential to how modern armed forces respond to threats, especially in contested and rapidly changing environments. We'll explore how weapon systems are being shaped by real-world conflicts, the technology behind them, and why availability and affordability are more important than ever for defence leaders. I'm joined by Gideon Weiss, RAFAEL's Vice President of Business Development and Marketing, as well as Brigadier General A, who is a former IAF pilot and a senior commander. He serves as a senior advisor to RAFAEL on advanced air superiority subjects, helping develop advanced ConOps with emerging technologies. First of all, gentlemen, welcome to the podcast.
Hello, thank you for having us.
Hi, Tony. Thanks for hosting us. It's great to be here.
So let's talk about specific weapon systems. RAFAEL has developed a number of precision systems that are designed to strike at long distances and with high accuracy. But can you walk us through the key systems in the portfolio and explain what makes each one distinctive?
Sure. So in general, RAFAEL has three types of air-to-surface weapons. Number one is gliding weapons, the SPICE, known as a SPICE family. And then there are air-breathing specimens. We will be highlighting two of them: the SPICE 250 ER, which is has a jet engine, a miniature jet engine, and then the Icebreaker, which is an air-to-surface cruise missile with a jet engine as well. But gliding, air breathing, and the third is the rocket-propelled weapons, the ROX air-to-surface weapon, which is actually a very fast-flying hypersonic missile that flies at very high trajectories, can maneuver, but has the same capabilities of tracking, navigating and tracking targets to the absolute precision.
And turning to you, Brigadier General A, obviously these weapons aren't being developed in a vacuum. What are some of the operational challenges? And I guess I'm thinking in particular around recent conflicts that are influencing how RAFAEL was designing and evolving these systems?
I think recent conflicts showed us two main domains. The first one is the A2AD, the anti-access aerial denial, is having radar air defense system pushing away fourth generation and fifth generation platform from the arena. And the second domain is having the inflation of high valuable targets, which are spread over a vast area. We see it in the Middle East. We see it, of course, in Russia, Ukraine. And then when you look, how can you tackle it from the operational perspective? If we'll take a look at a single target that needs to be struck, we see it's complex. Some of them require penetration. They require various warheads. They need to address these specific targets. They are heavily guarded, all of these targets, because it's the center of gravity of our enemy, usually. And you need something to carry a simultaneous strike in order to be able to destroy this target. So this from a single target perspective. The route to the target is also challenging. You need to address all the terrain, the air defense system along the way. Sometimes this missile flies for 1 hour, 2 hours to reach their goal. And you need to have the ability, of course, to plan all this route along the way. And we're looking at kind of on the high level, you need to carry out not a single strike. You need to take some four ships, some formation, in order to strike dozens of these targets, dozens of these simultaneous strikes. And from the operational perspective, something that comes from the air, something you do it from the ground. You need to have kind of a multi-service capability in order to be able to carry this out. And it starts from the single target, but it's the whole campaign when we look inside. See, this is the kind of the requirements that these weapons needs to address.
So when we think about launching a precision strike in a modern theatre, we're obviously talking about more than just the weapon itself. What are the core operational enablers that ensure success, particularly in a sort of electronically contested environments?
That's a great question. When you think about long-range precision strike and air-to-surface capabilities, it's really not only about the weapon itself, it's about everything that enables the mission. At the end of the day, you would have a weapon that needs to go navigate to allocate the target, and then home in on the target with the utmost precision, the most that you can give it. But there are a lot of things that need to happen for this to occur, for that mission to occur. So when we're talking about our systems, clearly, as you heard Brigadier General A, these are all combat-proven systems, and the combat-proven capability has to do with a lot of depth of understanding of all of these challenges. So I want to highlight a few of them and then pass it over to Brigadier General A to elaborate. The first thing we need is good intelligence. And intelligence could be coming in from so many sources. We usually today don't have a lack of intelligence. It's really the understanding of what we do with the intelligence. They could come from satellites, they can come from ISR UAVs, they can come from ISR aircraft, and we can, in many cases, see that there is an alliance between nations that can provide information and intelligence to one another. But at the end of the day, if you want to pursue something, if you want to understand what's important in the battlefield, you need a good system that will be able to get all of this data, understand from the data what is prioritized as high value target, and then pursue that target at a very short time. And that what we have today is an AI powered data fusion that enables us to apply AI in our intelligence systems such that we can do this. And what used to be taking us weeks and days is now hours. What used to take us hours is now seconds. And these systems allow us to process two or three more orders of magnitude more targets at the same time, which is really significant in terms of these saturated battlefield. The second thing is when we have the need to be able to respond very quickly, we need to reduce the sensor to shooter timeline. And so when you think about what needs to happen is not only the intelligence collection, but it's exactly what I said. These systems, these AI-powered systems, enable us to reduce the sensor-to-shooter timeline and improve the lethality, improve the accuracy of what we're doing. At the end of the day, there's also a need to be able to adapt to the contested arenas. We need to work with EW. We need to work against GPS jammers. This is one thing every nation needs to remember. You can count on one thing. Electronic warfare and GPS jamming is going to be in the battlefield. And if you do not have weapons and navigation systems that can function with that, independently of GPS, then they're going to be in trouble. These AI tools enable us to do just that. And I think I want to hand over to Brigadier General A to expound a little bit on the operational applications of that.
I think, one of our major lessons learned during this long campaign that we're having is the learning curve. It's when you prepare a weapon system, you're looking forward for your challenges. But what we see here, that since the campaigns are quite long, there's a learning curve. So I think the first issue is how you design a system which is robust enough to be relevant if the arena is changing. And it's changing within months. It's not changing within years. And this system that we develop should have a kind of a robustness by design. It should address long campaigns. It should address new threats emerging, not in a yearly manner, in a monthly manner, these kind of changes. This is the first issue. The second is having let's call it a kind of a self-reliant weapon, You don't need to be dependent on anything, whether it's GPS constellations, whether it's some required specific communication, should be kind of self-reliant in order to fully execute the mission by itself. And the third one is, of course, having, this full ecosystem from the mission planning to the execution of the mission itself. Because, striking target from a distance, it's quite challenging. It's what the target is, how we should strike it, what is the right aiming point, how we should come to this target, how we should navigate over it, how we tackle different threats along the way. It's like all the calculation that needs to be in the pilot's mind when he takes a jet to that target. The weapon should do it by itself. And now we can support all of this, this technology to put it, to embed it inside in order to deliver this probability kill to be high enough to be relevant. And we're addressing now, speaking about, of course, more than 90%. How should we relevant like that? All the things that we should embed inside. And, speaking about GPS independent weapons, it's the kind of thing that everyone speaks about. RAFAEL uses SPICE 2000, which is a GPS independent weapon for more than 20 years. So this is kind of the technology that we have in our house in order to deliver this kind of self-reliant weapon, which is, it's a short sentence, but it covers a lot underneath.
So that's a great summary of some of the operational considerations. And obviously the technology development is ongoing all the time. I'm just wondering what some of the core innovations are that are making these systems faster, smarter, and I guess more reliable in combat.
Right. So we talked about operational capabilities, but how do we achieve them? That's exactly the question. So you need navigation systems. Number one is GPS. Can we rely on GPS? Obviously, no. We need to be able to have GPS independent systems. So what we apply is electro-optic sensors and seekers. These sensors and seekers that rely on AI-driven scene matching technology that is using electro-optic sensing, enable these systems to scene match and anchor their location, anchor the navigation and anchor the location of the targets independently of GPS. And that allows not only to acquire the target and allocate the right aim point over the target, which is also the precision that we're looking for, it also allows for automatic target recognition and automatic and autonomous guidance. So when we have weapons like the SPICE 250 and the SPICE 250 ER, which is propelled by a jet engine that can fly to a very long distance, and it has communication, it could be either autonomous or it could have an operator in the loop, but then the electro-optic scene matching technology, which is AI-driven, provides that capability to the operators and turning us, the operators, from hard workers to decision makers. It's really easy to make decisions when you understand the situational awareness and what's going on in the battlefield.
I think the first thing is the ability for us to kind of implement, the ConOps inside. ConOps indeed, and the concept of operation is what really drives how you solve an operational challenge. How do we do that in a repeatable way? Let's call it that way. And I think what we embed is kind of the technology is having all this aspect of mission execution inside the system itself. It starts with the mission planning system. It goes into the core of the system itself, the way it executes the mission by flying over to the targets and doing that. And you have to it's a different layers of technology that needs to support that. It's in areas of navigation, of communication. It's area of, target acquisition and automatic target recognition. All this needs to be embedded inside in order to execute this full chain of, traditional kind of a sensor to shooter. You need to embed all that inside this weapon system in order to be relevant, facing, some targets are stationary. Sometimes we have some kind of uncertainty where they are. Some are maneuverable. And now we need to put this, when you're speaking of the long range capabilities, you need some system that have a kind of a man in the loop so you can influence about it. This is goes for the SPICE 250R, or something are more designated facing stationary target, like, for example, icebreaker. And each one has some different unique capabilities in order to address this mixture of targets that we need to address.
And then Gideon, I guess, taking a more of a strategic view, what makes RAFAEL stand out in the long-range strike landscape? I guess I'm wondering what the discriminator is for customers and end users that are coming to you for.
Certainly, when we pride ourselves in saying that we are combat proven like no other, it's not just a title, it's not just a slogan. We have the full gamut of these families. When you talk about gliding weapons, it's the entire scope of spice weapons, from the 2000 to the 1000 to the 250. All of these weapons, the spice family is a state of the art, but still already more than 20 years in the making. So they have been evolving throughout the years, throughout production and throughout their capabilities. Then there is the rocket-propelled ROX, which is I encourage our listeners to go about and look at the specification, what the ROX system is. It's taking the advantages of the electro-optic guidance that SPICE has and puts them on a rocket-propelled kind of a maneuvering ballistic missile. And that when you launch that from an airplane, you get the range, but you get the ability to go through and penetrate the enemy air defense, enemy protections, and be very effective in combat. And lastly, it's the air breathing. SPICE 250 ER and the Icebreaker are actually small cruise missiles. But when you think about the Icebreaker, its capabilities are very similar to some of the more known competitors in the world today, but it comes in an availability and a cost that is really making it a very different weapon, because now it's much more affordable. So think about a kind of a very effective, long-range, precision strike system that has the capability of a cruise missile, but does not cost like a cruise missile. So I think when we talk about this full gamut, it's really the agility to adapt to customers' requirements and to availability to deliver. All of these weapons provide the agility to adapt to new threats and be able to provide for more missions. And I think, again, I'd like to have Brigadier General A expound a little bit about the agility and how we use them on different platforms.
Now, I think when you look on the defense industries, most of them are now speaking kind of a boom, of long-range capabilities and affordable mass. But I think what RAFAEL stands out with is because we are doing this for decades. And we spoke earlier about the SPICE 2000 and its ability to tackle GPS-denied environments more than 2 decades ago. And I think by having RAFAEL as a kind of a, let's call it, a unique industry that stands along within, we have, on and on campaigns in the Middle East, unfortunately. We see the changes. We see the proliferation of advanced systems into the arena. We have more than a 1.5-year campaign currently. And we need to update and module the system to be relevant. It's not presentations. It's not slides. It's operational systems. And I think this is highly relevant because we have scars on our hand on developing these weapons. It's complex system. It's complex arenas. In order to be relevant and to assure mission success, it takes a lot of effort, a lot of technology, which we already proved and have. So this is where we are at RAFAEL.
And before we wrap up, I'd just like to ask for a takeaway. What are the 2 things that defence leaders should remember from this conversation as they think about investing in precision strike capabilities?
Sure. I think there are 2 main things to be said. Number one is that when you look at the wars in Ukraine and in the Middle East, everyone needs to think about the amount and the number of stockpile of weapons that they need, including the air-to-surface. It's not just artillery, it's not just air defense, it's also the air-to-surface capabilities, because these are the massive capabilities that change the theater and the battlefield. So you need high precision, you need that at scale, and it's not gold-plated. This is not just to the rich. Everyone needs that, and they need to be able to operate in GPS-denied environments. Number 2 is the fact that what we are doing in the world is not just providing this capabilities and selling them, but we can assure availability and readiness. And the way we do this is, number one, we have production lines here in Israel, but our number one strategic goal is to create the operational partnerships and the industrial partnerships through collaborations, through technology transfer programs, and in this way ensure that these systems are localized in their countries and that we have industry partners that can take this out and be able to manufacture and deliver, not just by relying on RAFAEL, but through the partnership. This means that no matter what we do, we can always count on be able to deliver within about 2 years. This is far faster than our industry norms and our competitors.
So that brings us to the end of this second episode in our two-part series with RAFAEL. We've obviously covered a lot of ground today, from the evolution of long-range precision strike portfolio to the operational challenges it's designed to meet, and then also the technologies enabling smarter, faster, more precise targeting. So let's thank Gideon Weiss and also Brigadier General A. Thank you very much for your time, gentlemen.
Thank you very much.
Thank you very much, Tom. It's been a pleasure.
Thank you both for your time and insights, and thank you as well to you, our listeners, for joining us. Don't forget to check out the first episode in the series, where we focus on directed energy systems and RAFAEL's 30-year journey to operational laser weapons. It's an episode you won't want to miss. Until then, take care.